Originally, I wanted to make a project that would turn my desk into a digital drawing board. I used 4 ultrasonic sensors to measure distance. Ultrasonic sensors emit a sound wave, and then measure how long it takes that wave to bounce off an object and come back into the ultrasonic sensor. This data is transferred to the Arduino, where the time is converted into distance. Okay, now back to the idea. If you put an object on the drawing board, the Arduino will produce a coordinate by measuring the distance from the ultrasonic sensor on the x-axis and on the y-axis. So then we'd have to go into a different program that would actually plot a lot of coordinates onto the Cartesian coordinate plane. The hope would be that you can actually draw like this. Next, I had to figure out how to actually turn that raw data from the ultrasonic sensors into a drawing. I spent a while trying to figure out a way to do this. Finally, I asked a friend and he told me about an application called Processing. Processing is an open source programming application that allows you to easily code for graphics. This application is super useful for me because it's really compatible with Arduino. Here's how it works. The ultrasonic sensor sends raw data to the Arduino, which processes it into distance. Then, Arduino sends it to processing, 1 byte at a time. We're sending data in groups of 4 bytes. The first byte is x, the second is y, the third is previous x, and the fourth is previous y. Next, processing will start plotting the coordinates. It'll connect the coordinates of x, y, and previous x and previous y together. Processing counts each of these bytes. Once it counts 4, it'll reset and take in 4 more bytes. This continues on, making small lines, recreating whatever occurs on the drawing board. This is supposed to allow you to draw in a certain space with like your finger or a pencil or something, and it should accurately record it, but that didn't really work out. The lines are pretty inaccurate, so I switched to a system of making small circles, but it still wasn't really accurate. It really came down to the fact that we're drawing in such a small space, and the ultrasonic sensors are only really accurate within about a centimeter. I started thinking of different ways that I could actually do this idea. The first one is to only have a single ultrasonic sensor on the y-axis and then like 3 of them on the x-axis. But I mean, this would be kind of accurate, but what would be the point? You can only draw on this tiny little margin. Oh wait, hold on. Maybe more sensors on one line wouldn't be a bad idea. Right now the y-coordinate's measured by a sensor on the top or the bottom. What if the sensors on the side that measure the x-coordinate could also measure the y? So for example, if I put a pencil in front of the bottom ultrasonic sensor, it would know the x-coordinate just because of how far away that pencil is from the sensor. But we also pair each ultrasonic sensor with the y-axis. Since we know that the bottom sensor is activated, we know that the y-coordinate will be on the bottom of the y-axis. A pretty big problem for this is for the y-axis. It seems like there are only 4 possible places that a coordinate could be, right? Because there are 4 sensors. I figured out how to increase the number of regions where a coordinate can be from 4 to 7. When an object is in a certain position in front of 2 sensors at once, both the sensors detect an object. If you use these areas and also areas where only 1 sensor detects an object, then you can increase from 4 to 7 regions. This isn't 100% accurate at all, but it's much better than it used to be. But I think there's still a couple more changes to make. The first change would be the ability to easily make shapes. Next would be the addition of buttons. Buttons can be used to switch between different shapes and different drawing styles. Next would be the addition of an erase or a clear button. And finally, it'd be really cool to have changeable colors controlled by something like a potentiometer. Okay, so final product. We added some shapes, buttons, a clear button, and also colors. The shapes added are squares and circles. There's a clear button, there's a button for circles, there's a button for squares, there's a button for the normal dot drawing, and then there's a potentiometer that controls color. The colors are blue, green, yellow, red, white, and gray. You can draw shapes by selecting a color, placing a pencil, finger, or other object on the paper, and then holding down a button until the shape is a good size and then letting go. To draw with dots, you can select a color, place a pencil, finger, or object in front of the sensors, press down the button, and then draw in front of the sensors. To stop, simply release the button. This feature is still not 100% accurate. However, the shapes actually turned out pretty well. I thought they'd be much more inaccurate, but being able to control the color and the size makes you feel like you have much more control. And that's it. hopefully I can keep expanding on this project. I really like the platform, and there are tons of more improvements I can make. Here's one last thing I figured out that I thought was super interesting. So, with the ultrasonic sensors, they're emitting a small sound wave, but you can't hear that with a human ear. I was looking over the footage, and I noticed that some of the audio had this really repetitive, fast tapping sound in the background. Turns out that's actually the sound waves from those sensors getting picked up on the microphone. I thought that was pretty cool. Thanks for watching, I hope you enjoyed.